So the key thing in combinations, again, the order does not matter. So that's going to be, from now on, all your questions get mixed together and you're going to be like, okay, does the order matter? Should I go down the combinations path or should I go down the permutation path? Where did that go? Oh my goodness. Where'd my highlighter go? That's terrible. Highlighter, hi. Oh no. Is it not going to let me highlight this? There we go. Order. Super, super important. There's a little typo here. Scribble out that line. That should just be an N on top and R on the bottom without a fraction line. We have our formula. That formula is on your formula sheet. But like I said, it's super easy to remember. Some special cases, right? And choose N. Has anybody in this class never played the game 52 Pickup? Anybody never played that game? Would you like to play? Okay. No, this is 52 Pickup is the game where someone says, you want to play 52 Pickup? And then you throw all the cards up in there and you say you have to pick up all 52. But that would be like 52, choose 52. You choose all of the cards. How many ways can you do that? If the order doesn't matter? One way. You're like, take them all. Okay? And choose one. How many ways can you choose one card? From 52, it's going to be 52. If 52 choose 52 is one way, that also means and choose 0 is one way. Right? Order doesn't matter. Pick no cards. Done. One way to do it. Don't pick any. So, and choose 0 is also one. And this part right here is the mathematical way of saying this. Choosing 6 is the same as choosing 4 from 10 because the bottom numbers have to add up. But the one before was like the mathematical way of saying it works for anything. Okay, so we're getting some questions. And one of the places where combinations is used a lot is in card games. Like in poker, there's 52 cards. You choose 5 of them. Does the order matter? No, you can rearrange them in your hand afterwards. So one of the reasons why people find poker so intriguing perhaps is because there are 52 choose 5. If I go to my calculator and I do that, 2598960. Almost 2.6 million different possible poker hands. So if I randomly take 1, 2, 3, 4, 5, if I randomly take this, you'll probably never see this again in your life. I got 10 of diamonds, 9 of clubs, 9 of clubs, 10 of clubs. This is pretty good. That's great. This is great. Usually I get nothing. But the chances of me pulling exactly this are 1 in about 2.6 million. Be amazed. You will never see this again in your life. You'll probably never see this math lesson again in your life either. Today's amazing. You're a super lucky day. Rarities happening all the time.
Yeah, for like a royal flush, does that mean there's 4 different ones?
Yes, that's your odds.
By 4?
Divide that by 4, and that's your odds of a royal flush. 1 in about 8 million. So go home. Not 8 million, 6 million. 6.5.
It says
650. thousand, sorry.
Yeah, 650.
Because 2.6, yeah.
That's
So
crazy.
you could go shuffle the deck of cards,
650,000 times.
pick 5 at random. Look, did I get a royal flush? No. Do it again. If you do a 600, now it's not guaranteed, but if you do it 650,000 times, chances are one of them would work. And it happens. Super crazy, but it happens. Okay. This what we've done already. This is the classic case of 2 decisions. You have to choose boys, you have to choose girls. A committee. So you see the word committee. On a committee, does the order matter? No. Be careful, because sometimes if they say, oh, the committee has a president, vice president, secretary, treasurer, now the order matters because there's different positions that matter. But if they just say a committee or a group, the order doesn't matter. But we still have 2 decisions to make. You have to choose which boys. Choices for boys, 15, choose 2. You have to choose which girls, 18, choose 3. And in between here, because these are decisions, you would multiply. So a class of students separated into 3 smaller groups. Right? Does order matter in groups, right? I make groups of 2. I say, okay, Riley, Brooke are together. Brooke says, I want a new group. Okay, I'll make a new group. It's going to be Brooke and Riley instead of Riley and Brooke. That's the same thing, right? The order wouldn't matter. So you have to say, okay, order doesn't matter. I have decisions to make. I have to decide who's in group A, who's in group B, who's in group C. How many choices do I have for group A? Well, I have, what does this add up to? 20? I have 20 people. I need to choose 8 to be in group A. Next, group B. I picked my group A. Everybody's standing inside my group A. How do I choose group B? Will it be 20, choose 5? No, why not?
Take away the one
Because the 8 people are already in group A. So now there's only 12 people left. I need to choose 5 of them. So you're in this class, I choose, okay, you 8 are in group A. I tell everybody I'm making 3 groups, groups A, B, and C. Then I choose my group B, and you haven't been chosen yet, and you're like, wonder what's gonna happen. And I don't say anything. So finally you put up your hand. I haven't been picked yet what group I'm in. I'm like, you're in group C. Good job. Why? Because how many people are left? 7. And you're choosing all 7 of them to be in group C. There's one way that can happen. And we get a number for this. Now, I'm going to leave some space here. And someone said, oh, but what happens if you made your decisions in a different order? Would it give you a different answer? If I chose group B first, then I say, okay, I'm choosing group B first. I'm going to go 20, choose 5. That's totally different numbers than I have up there. How many people are left? 15. How many do I have to choose for group A? 8 of them. The group C ends up being the same, 7, choose 7. Will this be a different answer? Okay. If we look at the formula, this would be 20 factorial, 8 factorial, 12 factorial. This would be 12 factorial, 5 factorial, 7 factorial, and this would be 7 factorial over 7 factorial, 0 factorial. And definition of 0 factorial is 1. If I do some canceling, check this out. The 7 factorials would simplify. My 12 factorial would simplify there. 0 factorial is just 1. And I would be left with 20 factorial over 8 factorial, 5 factorial, 7 factorial. If I look at example 2, this would be 20 factorial over 5 factorial, 15 factorial, and then 15 factorial over 8 factorial, 7 factorial, and 7 factorial over 7 factorial, 0 factorial. And if I cancel here, 15 factorials would cancel, and we get the same answer. And then I look at the answer and I say to myself, boy, that sure looks like a hippopotamus question. And then I say, well, if I took that class of 20 and in a hat, I put 8 A's, 5 B's, and 7 C's, all the number of arrangements, if I ordered the class from smallest to shortest to tallest, and then I got them to pick a letter out of the hat, it would be the same as rearranging 8 A's, 5 B's, and 7 C's. And as a hippopotamus question, this would be 20 factorial over 8 factorial, 5 factorial, 7. It's the same answer. Looking at the same question in a totally different way. I like this as a grouping, as a combination question with decisions, I think is the easiest. First decision, make one group. Doesn't matter which one. Then make your next group, doesn't matter which one next. And then whoever's in the last groups, whoever's left, will work out. And of course, this would all be multiplied together, whichever way that you did it. Well, let's get back to poker hands because it's a little bit exciting. Find the number of poker hands with no clubs. If I wanted to deal you a poker hand without any clubs at random, this would be a good strategy. Right? You like this strategy? What am I doing? I'm going through the whole deck. You be prepared to be amazed. I'm just telling you. Okay? There we go. All right. Mix them up. 5 cards. Or even all of it. There we go. Take a look. Did you get any clubs?
I don't think so.
I'm waiting. Did you? Amazing. No
It's
clubs.
actually a really good poker hand.
Are they? Oh, that's not that. 2 jacks. My other hand, 2 10s and 9s. So I still win. It's the moral of this lesson. Whatever happens in math class. Okay. Guarantee. We could do this all day. Do you think you'll get clubs?
Probably.
Probably. Well, let's see. Take 5. I took all the clubs out, by the way.
Oh.
But you never know. Like, did you get any clubs? No. Amazing. So if I want to get no clubs, does it make sense that if you take the clubs out, there's 39 cards? Now if you choose 5, you will get a poker hand. Will you have any clubs? No. And, sometimes you do combinations, and the answers are just pretty. Check this out. 39, math, choose 5 of them. Isn't that pretty? 5 7 5 7 5 7. Like, that's such a pretty number. And now part B. And part B, I'm going to have a little fun with your brains. Okay? I'm going to show you 3 different ways to do this question. And I'm going to be a salesperson. And I'm going to sell that all 3 of them are right. But all 3 could be completely wrong. Or 1 could be right and 2 could be wrong. Or 2 right. Or maybe all 3 are right and I'm now just playing with your brains. but I'm gonna be a salesperson. I'm going to give you 3 different ways to do this, and I'm gonna sell them as all right. And then if you think I'm a good sales, I might just quit my job and go try to sell, I don't know. What would be a thing that you could sell in Winnipeg that
Parts.
people don't need in Winnipeg? Like
Some type of insurance.
I am going to sell mountain climbing equipment to every Winnipegger. That is gonna be the best. I think I'm gonna convince everybody they really need it. If I can convince you that all 3 of these are definitely the right way to do this. Okay? All right. So, the number of poker hands with at least 1 club. What do I want to do? Okay, this is method number 1. I want 1 club. Well, nice. I've already got all 13 clubs separated here. I want at least 1 club. So I'm going to go to these 13 and I'm going to randomly pick one of them. How do I do that? 13, choose 1. Now I can take the rest of these cards, mix them back in, and take 5 more cards. Is it possible that I only have 1 club? Yes. Could I get more than 1 club? Absolutely. Right? Because they're mixed back in. So I have 51 more cards. I choose 4 more. I'm guaranteed to get 1 club for sure because I chose 1. And now I could get more clubs. So this is the number of ways of getting a poker hand because now I have 5 cards and I've got at least 1 club. Method number 1. Method number 2. Well, I just counted how many have no clubs. So if I take all the poker hands, which we figured out before was 52, choose 5, and I use the not strategy and take out all the ones that have no clubs, what's going to be left? Poker hands that have at least 1 club. That also is a great way to do this question. I could also break this up into cases. Case 1, and if you do cases, you have to make sure each case is separate. So I'm going to count exactly 1 club. So very much like the first one. Excuse me, I choose 1 club, then from the other 39 cards, I choose 4 more. Case 2, I'm going to count how many hands have 2 clubs. Well, I have my 13 clubs, I choose 2 of them. And from my other 39 cards, I choose 3. Gives me 5 cards, that's exactly 2 clubs. Case 3, you see there's going to be 5 cases. It's a little bit annoying because it's all the same. 13, choose 3. And of my other 39 cards, I choose 2 more. And case 4, 4 clubs. I go 13, choose 4 of them. And from the 39 other cards, I choose 1 more. And finally, case 5. All 5 of them are clubs. So I just have to go from my 13, choose all 5. I don't choose any from the 39. If I add up all of those cases, since I've counted clubs, hands with 1 club, with 2 clubs, with 3 clubs, with 4 clubs, with 5 clubs, all those put together would be at least 1 club. All right. How did I do? All 3 seem good, right? Are all 3 bad?
No.
No. Mr. JR wouldn't do that to us. I should, not me. I should just. By the way, last 3 weeks, made it up. We're behind. We have to redo things. And some of you are like, didn't matter, it didn't make sense to me anyways. I'm the same place I was 3 weeks ago that I am now. Well, what could we do to find out if these are all right or all wrong? I guess we could look at the answers. If we looked at the answers and all three answers were the same, then you're down to two possibilities. All right or all wrong. So let's look at the answers. I'll do it quickly on my calculator here. Oh shoot. I'm trying to do it quickly on my calculator. Answer for the first one. 3, 2, 4, 8, 700. Second one. 202, 3, 203. And the last one. Okay. They aren't all right. I at least lied to you once. Maybe all of them are still wrong. I could have lied to you still 3 times. Or maybe I lied to you twice and told you the truth once. Sometimes I take a survey and I ask students which one, after I go through all 3. If you liked it and feel confident, put up your hand. And you can put up your hand for all 3 if you liked all 3. And then we go and put the answers up. And it's funny because sometimes people are like, well, I don't like the last one, but it has to be the right because it's the most work and looks the worst. So I have people who have said that in the past. The first 2 have to be wrong because they were too easy. But looking at the answers, there's one that you can actually say for sure. You can say the first one is wrong for sure. Does anybody know why the first one for sure you can say is wrong? There's something we learned today that would say right away, yeah, first one's definitely wrong.
There's 52 cards in the deck.
There's 52 cards, yeah, but we chose one out.
Oh, yeah, okay.
And we put the other ones back. Like it makes this, what is wrong? Like the first one is wrong. And there should be a way you can see there's wrong. Okay? Let me phrase it to you in numbers. Of the 2.6 million possible poker hands, 3.2 million of them have at least one club. When I say it that way, do you see what went wrong? There's 2.6 million, about 2,598,960 poker hands. And 3,248,000 of them in 700 have at least one club. We have a problem. That number is bigger than the original. Okay. What went wrong? Why? Because strategy 1, like, it makes sense. I sold it well. What's the problem with strategy 1? Problem with strategy 1, and the thing you have to be careful when combining decisions with combinations, is you have to make sure that your decisions don't overlap. The cases worked out because here I chose clubs, here I chose not clubs, they don't overlap. But in the 13 choose one, and I'll demonstrate it with an example. If I choose a club, here we go. I chose 10 of clubs. Go figure, right? I chose the 10 of clubs. Then in the 52 other I mix the other ones back in. I choose them. I could have got, ace of hearts, 7 of diamonds, 3 of clubs, and 5 of spades. That could be a possibility, right? Then I do it again. And I do my 13 choose one, and I choose the 3 of clubs. Then I go mix the other cards in, and when I pull them out, I get the ace of hearts, the 7 of diamonds, the 5 of spades, and the 10 of clubs. In this method, that's counted as different. But are those not the same poker hands? So when you have overlap, and you could choose the same thing here, over here again, you might count too many. Right? How many too many did I count? Oh, I was only off by 1.2 million. Right? I would love that. I'd love to go to 7-Eleven, pay $10 for a Slurpee, and they gave me change and they were off by 1.2 million. I'd be happy. Right? That's a big mistake. Off by 1.2 million. So here, this choice and this choice don't overlap. Our cashiers and clerks didn't overlap. You can use decisions with combinations, but you have to be careful that your decisions don't overlap because then you might be adding order when you don't want to.
I hate the 10 of clubs. I hate the 10.
Hate the 10 of clubs. It's gonna give you nightmares.
Yeah.
Say stop. Anytime you want.
So,
Unbelievable. What?
stop because I'm scared.
How did you do that?
Wait, did I actually do that?
Well, I waited till you said stop. You should have said stop a lot
No, you're
sooner.
not messing with me. Like, you're not messing with me at all.
Amazing.
Promise. Say
Promise.
on God.
Well, it's magic, right?
It's a magic trick. You couldn't. I mixed it up. You couldn't possibly do it again.
No, how did you do that?
Couldn't possibly do it. Say stop. Stop.
Wait, like, how are you doing that? Is it just like,
Did I say stop? You said stop. You did that.
oh my